Hey everyone, in this video we're going to take a look at how we can compute the adjacency matrix and the determinant of a 3x3 matrix. So we're given the matrix here, and let's start by calculating the determinant. And to calculate the determinant of a 3x3 matrix, we've got to do what's called a cofactor expansion. And the cofactor, it's got like some pretty confusing looking formula, and it's honest. I'm just gonna show you like the process that you can remember, and then like the formulas, like we are applying them. But if you're looking off of the formula, it's gonna be a lot harder to like think of actually compute this problem. But if you can just remember this process, like this will be how to compute them in like all cases. So let's take a look at determinant. Determinant of A. So we do a cofactor expansion along any of the rows or the columns that we choose, and usually we want to use like an easy one. So if like a row, in this case, it's kind of hard to do this because we don't have that many zeros. But sometimes you can strategically choose which rows or columns depending on like how many zeros will be in your calculation. This one, that doesn't make a big difference. But actually, before we get into the determinant, let me. I'm going to write out something that I think will be useful for a 3x3 matrix, and I'm going to write out all of what's called the cofactor signatures. And basically every cofactor is either plus or minus, depending on like what the exponent of our -1 term is from the formula. But if you can just remember this, top left corner always start as a positive, and then you're going to alternate depending on the size of your matrix. Then just keep this in mind. This will always be true. I just like writing it off to the side so I can remember. So what we're going to do here, I'm going to copy down this matrix a couple more times here. Let's choose the first row to do our cofactor expansion along. And what we do is, so I'm going to take I'm going to start with the first entry of my first row, which is the 2. So I'm going to write out positive 2. Remember, positive because it's the first entry, or upper left entry. That's what it corresponds to in my my cofactor signature matrix, times 2. And then if you see here, I'm going to do a vertical line and a horizontal line, with the intersection being that whatever cofactor I'm working with. And you'll see that I am left with these 4 entries: -1, 1, 3, and 1. So what I'm going to do is multiply by the determinant of a 2x2 matrix of those entries that I haven't crossed off. And a 2x2 is a lot easier to calculate. So I've done that. So let's take a look at the next one now. Okay. The next, I'm doing a cofactor expansion along the first row. So I'll go to the next entry of that row, and you'll see it's a 0. And you'll see it corresponds to a minus sign in my cofactor signature matrix. So usually that would mean we do -0 times, and then we would cross off, like same way that we did for the last one, and then we'd have 1, 1, 0, 1. But we're multiplying this by 0, so I'll write it out anyways. But we know this one's going to be 0. So we have this. Now we're on the last entry, which is a 1, and it corresponds to positive. So I'll do plus, and then we said +1. And we'll do the same thing, that vertical and the horizontal line. And we're left with 1, -1, 0, 3. So I've got 1, -1, 0, 3. And this is my determinant. So let me just actually compute these, right? So this will be 2, and then so our determinant will be -1 times 1 minus 3 times 1. -0 plus, this is 1 times, this is 1 times 3 minus 0 times -1. So this will be 2 times, and then we've got -1 minus 3 is -4, minus 0, and then this plus, so this will be plus, and then we've got 3. So we've got -8 plus 3, so -5, which means our determinant of A is -5. And that's our answer. So let's take a look at how to do the adjacency matrix. So the adjacency matrix, it's kind of similar, except a little bit more tedious. So the adjacency matrix of A is going to be a big old matrix here. Let me scroll down. Where every entry is going to have the same signature as the cofactor, except instead of like multiplying like what the entry of the matrix is, like you see how we multiplied by like 2 and 0 and 1, and we're just going to take the determinant part of our cofactor and use those as our entries. So this is still going to be plus, minus, plus, minus, plus, minus. We're going to have the same signatures here, but we're just going to now take a look at the determinant of like that corresponds to each of the cofactor like entries that we have. So the first one I know is -1, 1, 3, 1. The second one we've got 1, 1, 0, 1. And then we've got the last one. We have 1, -1, 0, 3. Oh, and while I'm here, remember that we also have to transpose this matrix as well. So let's take a look at the middle row. Okay. So the middle row up here. Oh, let me scroll up. So we'll do the middle left. So we're left with 0, 1, 3, 1. 0, 1, 3, 1. Next, we have 2, 1, 0, 1. So we have determinant of 2, 1, 0, 1. What do we have next? We have 2, 0, 0, 3. 3. Great. Okay. Next we'll do the bottom left. So the bottom left will be 0, 1, -1, 1. The middle, bottom middle, we have 2, 1, 1, 1. And then the bottom right, finally, we've got 2, 0, 1, -1. Okay, now I can finally scroll down here. This is what we have, and it looks really ugly. And let's take a look at just computing all of these, right? So the first one we have -1 minus 3, which is minus 4. Yeah, minus 4. Next we have, so we have, remember, negative times, so this is going to be 1 minus 0. In our upper right, we have 3. Yeah, so this is just 3. 3 minus 0. Now, working down, we have negative. This is 0 minus 3. We've got 2. We have minus 6. This will be 0 minus -1. So this will be positive 1. And then we have negative. This is 2 minus 1. So that's -1. And then -2 in our bottom right. And remember, this is all transposed. Don't forget about that. Cool. So finally, we've done all the tedious work. let's just double check all of our cofactor signs are correct. We've got negative, positive, yeah, negative, positive. Okay, everything's looking okay. Great. So now we just have to simplify this and take the transpose. Great. So we have, let me simplify these. Okay, so -4 to -2 as our diagonal. And now I'm going to transpose this in the same step. So my 3 will now be in the bottom left. My 1 will be in the top right. My +3 will be on the middle right. I've got -6, and then the bottom and the top will switch as well. So, but those happen to be the same. So we have -1 and -1. And finally, this is the answer. This is our adjacency matrix. And the really great thing about calculating the determinant in the adjacency matrix is that it provides a really easy way for us to calculate the determinant, the inverse of a 3x3 matrix, because the inverse is actually just 1 over the determinant of A times the adjacency matrix of A. So we can easily go from our like both of these calculations into finding the inverse. And notice that since we're dividing by the determinant here, this also shows that the determinant is we can't calculate the inverse if the determinant is 0, because we can't divide by 0. So what was our determinant? What did we say that was going to be? That was -5. So we've actually got -1/5 times our adjacency matrix. So this is -4, -6, 3, -1, 2, -1, 1, 3, -2. And you could factor that in, but it's really the same thing. So this right here would be our inverse of the 3x3, piecing everything together. Great. So I hope this video was helpful, and we'll catch you in the next video.